Magnetic field induction at the center of a coil bent in the form of a triangle carrying current. So in the diagram we have a coil which is bent in the form of a triangle. AB prime C is the coil which is bent in the form of a triangle. A current I flows through the coil clockwise. A current I flows through the coil clockwise. Now we can draw three medians and point of intersection of that three medians is the centroid, and we have to find magnetic field induction at that centroid. We can extend the median up to the side AC. B prime M is the perpendicular or median from the point B prime on the side AC. B prime P. P is a centroid, and we have to find magnetic field induction. That means B equal question mark at the centroid P. A, small a, is the perpendicular distance of the centroid P from the side AC. The oblique distance AP makes an angle phi 2 with the perpendicular distance A. The oblique distance AP makes an angle phi 2 with the perpendicular distance A. And oblique distance PC makes an angle phi 1 with the perpendicular distance A. Phi 2 is the angle subtended by the oblique distance AP with the perpendicular distance A, and phi 1 is the angle subtended by the oblique distance PC with the perpendicular distance A. L is the length of each side of the triangular shaped coil. Here L is the length of the side AC. L is the length of the side AC. The magnetic field induction. The magnetic field induction. The magnetic field induction magnetic field induction at the centroid P of a coil bent in the form of triangle. The magnetic field induction at the centroid P of a coil bent in the form of a triangle. In the form of a triangle AB prime C, AB prime C, triangle AB prime C. Carrying a current I, is given by B equal magnetic field due to the arm AC plus magnetic field due to the arm AB prime plus magnetic field due to the arm B prime C at the centroid. Magnetic field magnetic field or magnetic field induction at the centroid P due to the arm B prime C. Magnetic field at P due to the side or arm CA. CA. Similarly, magnetic field at the same point due to the arm AB prime at the point P, and magnetic field at the point P due to the arm B prime C equal BCA plus BAB prime, BCA plus BAB prime plus B prime C equal 3 BCA. Since BAB prime equal B prime C equal BCA, magnetic field induction due to the three sides will be same. Therefore, putting the value of BCA, we get 3 mu 0 by 4 pi I by A sine phi 2 plus sine phi 1. Phi 2 and phi 1, the values of phi 2 and phi 1 are 45 degree and 45 degree. Phi 2 is the angle subtended by the oblique distance AP with the perpendicular distance A, and which has the value 45 degree. Phi 2 is equal to 45 degree for this coil bent in the form of triangle. This oblique distance AP makes an angle phi 2 with the perpendicular distance A, and the value of this angle phi 2 is 45 degree. It should be 60 degree, and again the value of that angle phi 1 is 60 degree. Phi 1 is 60 degree for uh, the coil bent in the form of triangle. 3 mu 0 by 4 pi I by A under bracket sine 60 degree plus sine 60 degree, because we know that angle between two medians for a equilateral triangle is 60 degree. So mu 0 by 4 pi 3 I by A root 3 by 2 under bracket root 3 by 2 plus root 3 by 2 bracket closed. Therefore, B equal mu 0 by 4 pi 3 root 3 I by A. Now, the perpendicular distance A from the centroid to the side of the triangle is A, small a. If we draw the diagram, equilateral triangle, and we can draw a median, that means perpendicular from the highest point to the base. B prime, BP, BM is a perpendicular on the side AC of this triangle. B prime M is a perpendicular. B prime M is a perpendicular on the side AC. Length of each side is L, and we can draw other two medians. A is the perpendicular distance of the centroid P from the side AC. In this case, this perpendicular distance A is equal to PM. PM is 1/3 of B prime M, 1/3 of that perpendicular B prime M. 1/3, 1 by 3 root over AB prime square minus AM square. L is the length of each side. 1 by 3 root over Now AB prime is L root over L square minus L by 2 whole square under square root. Therefore, A equal L by 2 root 3. If we simplify, then we get L by 2 root 3. That is the perpendicular distance of the centroid from the side AC. From the side AC equal to L by 2 root 3, where L is the length of each side of the triangle. Now we can put the expression of this is the resultant magnetic field induction, which was mu 0 by 4 pi root 3 I by A. And putting the expression of A in that expression, in that equation, we get B as A equal to L by 2 root 3. Therefore, A is what? Perpendicular distance of the centroid P. A is the perpendicular distance of the centroid P from the side AC of the triangle, from the arm AC or CA of the triangular shaped coil AB prime C. So B was mu 0 by 4 pi 3 root 3 I by A. It was 3 root 3 I by A. B was mu 0 by 4 pi 3 root 3 I by A. So here we can write down the expression again, which is 3 root 3 I divided by A equal mu 0 by 4 pi 3 root 3 I whole divided by L by 2 root 3. Therefore, B equal mu 0 by 4 pi 18I by L. 18I by L. 18I by L. So this is the resultant magnetic field induction. Resultant magnetic field induction at the centroid of a coil, which is formed bent in the form of a triangle. Here E is a perpendicular distance of the centroid from the side CD, and L is length of each side of the coil. Length of each side of the triangular coil of the coil or of the triangle. We get V as mu 0 by 4 pi 18I divided by L, which is the magnetic field induction. Magnetic field induction at the centroid P, at the centroid P of the coil bent in the form of triangle. At the centroid of a coil bent in the form of triangle, carrying current I. Magnetic field induction at the centroid of a coil bent in the form of triangle carrying a current, and which is B equal mu 0 by 4 pi 18I by L. Now we can compare the coil bent in the form of a square and a coil which is bent in the form of a triangle. This is a coil which is bent in the form of a square, and on the right hand side it is a coil which is bent in the form of a triangle. I is the current which is flowing through the coil having square shape. L is the length of each side of the coil, and we can draw two diagonals. And here the magnetic field induction at the center of the coil is vector B, which acts inwards. Magnetic field induction due to the four sides of the coil is vector B, which acts inwards, and on the right hand side the current I flows clockwise through the coil, which is bent in the form of triangle. And we consider the point, the centroid P. At that point, this is the perpendicular distance of this centroid from its side, and here left hand side we can denote the perpendicular distance of the center from the side of the square. And magnetic field induction at the centroid of the triangle is vector V. Vector B acts inwards. Vector B acts inwards, and this magnetic field vector B acts perpendicular to the plane of the coil. And L is the length of each side of the triangle. Now at the point P for the square, magnetic field induction B is mu 0 by 4 pi 8 root 2 I by L, 8 root 2 I by L. And here on the right hand side for the triangle at P, means at the centroid, magnetic field induction is mu 0 by 4 pi 18 I by L. 18 I by L. So V equal mu 0 by 4 pi 8 root 2 I by L, that is the magnetic field at the center of the square. And V equal to mu 0 by 4 pi 18 I by L, which is also the magnetic field induction at the centroid of the triangle. Also, the perpendicular distance of the centroid from each side of the square is A, which is L by 2, and here perpendicular distance of the centroid from each side of the triangle is A, which is L by 2 root 3. And this magnetic field acts inwards with respect to the plane of the coil. Both the magnetic fields act inwards with respect to the plane of the coil. So this is the comparison between a square and triangular shaped coil.